the P1 June 2021 variant 2. Now what we will do is that we will divide the video into two parts. So usually a P1 or a P3 video, question number 1 till 7, this will be part 1 of the video, part A, and the second part, which is part B, that would be question 8 till the end, which could be question 11, which could be question 12. So that's how we will go about it. It's roughly half and half. So now the time is 10:25. We are starting at 10:25 for the first part, and let's see how much time does it take. Question number 1. Question number 1 looks like a quadratic question. There is almost completing square. Why do I say it almost completing square? I'll just explain in a short while. And something to do with roots, so therefore it would be about discriminant. Now the very first part we are starting, 16x square minus 24x plus 10. Make sure the coefficient of x square is 1. So x square minus 24x over 16 plus 10 over 16. 16 as it is, x square minus 3 over 2x plus bracket square minus bracket square plus 10 over 16. I'm not reducing the last fraction. This is negative 3 over 2, half it, negative 3/4, negative 3/4. Rewrite the first three terms as a perfect square. So this is 16. This is x minus 3/4 whole square. This is negative 9 over 16. And this is 10 over 16. So now if I simplify this thing, because the denominators are the same, this comes out to be positive 1 over 16. When I'll open up the bracket, this 16 will multiply with both of them. So this is 16x minus 3/4 whole square. 1 over 16 into 16, that is positive 1. This is 4 square x minus 3/4 whole square plus 1. This is 4x minus 3/4, the whole thing square plus 1. Therefore, writing on the right hand side of the squiggly wiggly, this is 4x minus 3, the whole thing square plus 1. Compare it with this thing, 4x plus a whole square plus b. 4x plus a whole square plus b. If the examiner was asking me to state these separately, I would say a is negative 3 and b is positive 1. So that is the first part. What else is it asking for? It is given that the equation where k is equals to, where the equation equals to k, where k is a constant, is exactly one root. Find the value of this root. Now let me do this question by two different methods. So first of all, method 1 and then a method 2. So this is method 1 and this is method 2. Method 1 is applying the concept b square minus 4ac equals to 0. That is one root. So therefore 16x square minus 24x plus 10 minus k equals to 0. This is your ax square. This is like your bx, and this whole thing is c. So therefore b square minus 4 into 16 into 10 minus k equals to 0. 576. This is 64. 10 minus k equals to 0. Negative 64. 10 minus k is negative 576. 10 minus k equals to, let me grab my calculator. So therefore this is 576 divided by 64, that is 9. Therefore k comes out to be 1. That's a straightforward way of working it out. But there is also another way. That another way is, if this thing is written in the completed square form, which we already have, which is either choose any one of them. For example, this one. So this is 16, the original completed square form, x minus 3/4 whole square plus 1 equals to k, and this is 16x minus 3/4 whole square plus 1 minus k equals to 0. If I compare it with something called ax minus h whole square plus a big K, and this is your h is the x coordinate of turning point, and this k is whatever is in the red bracket, which is 1 minus k. The two k's are different. That's the symbol that we use. So just to avoid any confusion, let me label this thing as q. So this is q and this is q. Now a curve will touch the x-axis. A curve will touch the x-axis, and therefore it will have only one root. Only one root if x-axis is tangent to curve. So when x-axis is tangent to curve, therefore y coordinate of turning point is 0. This is the y coordinate of turning point. So 1 minus k equals to 0. Therefore k is equals to 1. This is also a beautiful alternative approach. I'm not saying that you should do this, but I'm saying that this is possible. So that's why I have done two different approaches for this one. Let's move to question number 2. The graph of y is equals to fx is transformed. So therefore this is a question of transformation. So transformation of graphs. In O-level maths, there was transformation with matrices, the reflection and the rotation and the translation and the enlargement. Now this is transformation of graph, a very, very interesting topic. It says y is equals to fx is converted into something. So it's converted using two steps, the first one and the second one, and it becomes y equals to 2f bracket x minus 1. What is happening? First of all, write this thing into fx minus 1. Therefore, this first one is shift graph horizontally 1 unit to the right. That is the first transformation. The right doesn't look very right. And then what happens? Then the graph is stretched parallel to y-axis by a factor of 2. So that is what is happening for 3 marks. Describe fully two single transformation. That's description in detail. The red one and the purple one. Now even more stronger question. The curve y is equals to sine 2x minus 5x is reflected in the y-axis. First thing, that is reflection in y-axis. And then second thing, it is stretched by a scale factor of 1/3 in the x direction. Now the first thing is, when we have y is equals to f of negative x, that is reflection in y-axis. That's the first thing. And when we have y is equals to f of ax, that is a stretch along x-axis. The y coordinates are unchanged, but x coordinates are multiplied by 1 over a. That is what is happening. Now, if this concept is clear, you can easily do this question. Write down the equation of the transformed curve. So the original equation is y is equals to sine 2x minus 5x. First transformation reflected in y-axis. So the first one will become y equals to negative sine of 2x, and this is I think 5x, so let me correct myself, and this negative will become positive, that is positive 5x. That is the first thing. This negative, this positive, that is change. So this is multiplication by negative sign. Multiplication by negative 1. That is what is happening. Now what else will happen? Let me shift it a little bit to the side. The second thing that would happen, that is of this thing, something like this. It is stretched by a scale factor of 1/3. So 1/3 is like 1 over a. In other words, a is 3. So if a is 3, write 3 over here. So therefore y equals to negative sine of 6x plus 15x. That is the answer for this particular part. Now let me give you a hint also. Remember sine 2x are 2 cycles in 360 degrees. So the x coordinates, for example, 90 was firstly giving you 1. But now 45 will be multiplied by 2, becoming 90 will give you 1. So the x coordinates were halved because of this 2. That's the same thing over here. Now when you check the mark scheme, what you will see is that this thing, someone, the examiner of course, has written this thing as sine of minus x plus 15x. This is also correct. Why? Because they have applied the rule sine of negative theta is the same thing as negative sine theta. So this rule is applicable over here. As such, this answer is perfectly valid. So now 2 questions are done. Let's move to the third question. What is the third question all about? The equation of a curve is such and such. The following points lie on the curve. That equation of that curve is given. So therefore, what is it asking for? It's asking for non-exact values are rounded to 4 decimal places. That's the first thing that I see. And then it says the point A is such and the point B is such and so on. So now it's looking for find the value of k. So that's simple. The equation is y is equals to x minus 3 square root x plus 1 plus 3. So when x is equals to 2, plug the value 2 minus 3 square root 2 plus 1 plus 3. Use a calculator and then you will get this particular answer. So that is the working for this particular part. Now what else is it asking for? Find the gradient of AE, giving your answer correct to 4 decimal places. Now in this particular part, this is gradient formula. A is 2 comma whatever that value is, and E is 3 comma 3. And you would apply the gradient formula. So gradient of AE. So when you do the calculation, so the first of all, this answer is 1.2679 and this is 1.2679. 1.2679 minus 3 divided by 2 minus 3. So therefore this comes out to be 1.7321. The negative and the negative cancels. Now what does it say? The gradient BE, CE, DE are such and such. So this is BE and this is CE and this is DE, and the first one was AE, that is 1.7321, and AE is 1.7321. Now look at the 4 gradients. The point E is constant. The 4 gradients are 1.73, 1.97, 1.99, 1.999. So it's getting closer and closer to 2. State, giving a reason for your answer, what are the values of the 4 gradients suggest about the gradient of the curve at this particular point. Now remember, we went over this idea and this is exactly the same question that we have done. And what happens is that when you, I think this diagram would be beneficial for this one. If for example this point, let me erase it, and for example this point is your E, and this point is like, for example, this is A and this one is B and this one is C and this one is D. So closer you move to E, the tangent would be giving you the right gradient. That is the concept of first principle. So this particular question is about differentiation. It's about the concept of first principle, and what it says is that uh, what does the four gradient suggest about the gradient of the curve at E? So since the point D is closest to E, gradient of dA is approximately equal to gradient of tangent at E. So this is 1.9997. So let's say that this would be equal to 2.000. So therefore, what it says is that the uh, part of the graph at which the tangent is drawn, these 2 points are so close that it behaves like a straight line. That is why we say dy by dx is gradient of tangent to the curve at this particular point. So since D is the closest, so the gradient of DE is almost the same as gradient of tangent at E. So this question is done. 3 questions down. Now it says the coefficient of x. Now this is a traditional binomial question. So this is binomial expansion of P1 naturally. And it says the coefficient of x in the expansion of such and such is P. So first of all, write this thing as 4x plus 10 over x, the whole thing cube. Coefficient of x. How do I find the coefficient of x? The 3-step method. So first of all, write NCR, a raised to power of n minus r, b raised to power of r. 3CR. Actually, you can also, what you can do is that you can write out the first 4 terms and one of them will be the coefficient of x. So you can do that, or you can follow the traditional way. That is 4x, 10x minus 1 raised to power of r. This is 3 minus r. Gather powers of x. This 1 multiplies with 3 minus r. This minus 1 multiplies with r. So therefore 1 into 3 minus r plus negative 1 into r equals to, we are looking for coefficient of x. So power of x is 1. 3 minus r equals to 1. Minus 2r is negative 2. Therefore r comes out to be 1. So therefore 3c1. This is 4x raised to power of 2, 10 over x raised to power of 1. 3c1 is 3, 4 square is 16, x square is x square, 10 raised to power of 1 is 10, 1 over x is 1 over x. Double check. This is 2, this is 1. So that's a coefficient of x. So 3 into 16 is 48. So coefficient of x is 480. That is the first part. What else does it say? The coefficient of 1 over x in the other expansion is such and such. So now the other expansion is 2x plus k over x square raised to power of 5. And we are looking at coefficient of 1 over x. And we are calling it q. And coefficient of x, we are calling it p. So let me label both of them. So coefficient of x is p. Let me get this straight. Okay. And coefficient of 1 over x is q from 2 different ones. So now the same rule applies, NCR. And this is a raised to power of n minus r, b raised to power of r. That is 5CR. And then a is 2x raised to power of 5 minus r. And this is kx minus 2 raised to power of r. Again, gather the powers of x, equate it to the power of required term. What is the power of required term? That is x raised to power of minus 1. So 1 into 5 minus r. Let me go down a bit. 1 into 5 minus r. Minus 2 into r equals to negative 1. 5 minus r minus 2r is negative 1. Minus 3r is negative 6. Therefore, r comes out to be positive 2. R will always come out to be positive. Or it could come out to be 0. That means it's the first term. So therefore 5c2, 2x raised to power of 3, k over x square raised to power of 2. Let me get my coefficients correct. I think it's correct. 5c2 is 10, 2 cube is 8, x cube, k square is k square, and x square is 1 over x4. Let's double check. This is cube, this is 4, that's 1 over x, perfectly right. So therefore coefficient of 1 over x is 10 into 8 is 80. So that is 80k square. Now this thing is denoted by P. This thing is denoted by Q. What does it say? P is equals to 6Q. So P equals to 6Q. 480 is equals to 6 times 80 times K square. So therefore K square comes out to be 1. Therefore K could be -1. K could be +1. What does it say in the question? Find the possible values of K. This is accepted. This is accepted. So therefore both are correct. 4 questions down. Now comes the question that looks like quadratics, actually, sorry, functions, quadratic functions. So this is a quadratic expression, more quadratic. Okay, so let's get started. It says the function f is given by such and such. Find and simplify an expression for f of fx. So f of fx, that is too simple. That is 2 into fx, the whole thing square plus 3. That is 2 into 2x square plus 3, the whole thing square plus 3. That is 2 into 4x square, 6 plus 6, that's 12x, 4x4 plus 12x square plus 9 plus 3. And this is 8x4 plus 24x square plus 18 plus 3. And therefore this comes out to be 8x4 plus 24x square. And let me get this straight. So this is 18 plus 3 is 21. That is the expression. And now it says f of fx is equals to this thing. I think they have lowered the standards of function. Let's hope they keep it this way. They're not asking very challenging questions nowadays. Let's see for how long. 34x square plus 19. So therefore 8x4 plus 24x square plus 21 is 34x square plus 19. 8x4, 24 minus 34 is -10x square. 21 and 19, the difference is 2 equals to 0. Therefore this is 4x4 minus 5x square plus 1 equals to 0. Make a substitution. Let m equals to x square. Therefore x4 is m square. So 4m square minus 5m plus 1 equals to 0. Looks like it's factorizable. So 4m square minus 4m minus m plus 1 equals to 0. 4m m minus 1 minus 1 m minus 1 equals to 0. m minus 1, 4m minus 1 equals to 0. Therefore m is equals to plus 1. Therefore m is equals to 1/4. But what is m equals to? M is equals to x square. And also remember this thing, x should be positive. So but m equals to x square. So therefore x square is 1. Therefore x is plus minus 1, except only x equals to 1. X square is equals to 1/4. X is plus minus half, except only x is equals to half. So that is the answer for this particular question. 5 questions down. Question number 6. A single part question. And it says point A and B have coordinates such and such. So we have A, which is 8,3. We have B, which is PQ. Equation of perpendicular bisector of AB is such and such. So let me draw a small diagram. Let me draw this. For example, this is A and this is B, and B is P comma Q, and A is 8 comma 3. Midpoint, the line through the midpoint is called the perpendicular bisector. So the perpendicular bisector would be somewhat like this. Okay. The equation of this perpendicular bisector is y is equals to minus 2x plus 4. Correct? Now, what is the perpendicular bisector? Not only it's perpendicular, it's bisecting. That means, first of all, A is 8,3, B is PQ. Let me find the coordinates of the midpoint in terms of this. This is 8 plus p divided by 2, 3 plus q divided by 2. This midpoint is also part of this line. So midpoint part of this line, therefore y is 3 plus q divided by 2, that is minus 2, 8 plus p divided by 2 plus 4. This is your equation 1. Of course, you need to simplify it. Second equation, gradient of this line is negative 2. Gradient of the perpendicular would be plus half. So A is 8, 3 and B is PQ. So gradient of AB is 3 minus Q, 8 minus P, that is equals to plus half, that is equation 2, and then you solve simultaneously. So I'm just gonna save like 2-3 minutes on this one. That's for you to try. So question number 6 actually was about which thing? This is about your basic coordinate geometry, CG. Question number 7, and this will be the last question for the first part. So question number 7, this looks like what? This is circle and something circle. Okay, so circle, circle. So this is coordinate geometry and circle. That is the first part. That is question number 7. Now it says the point A has coordinates such and such, and the line L has gradient negative 2/3, and the circle has a center 5, 11. So let me draw a circle and let me label a point 5, 11. So somewhere here is 5, 11. So this is 5, 11. Let me label this thing as C. Therefore 1, 5 would be something like this. So this is 5, 11. X coordinate is 1 and then 11. 1, 5, my bad. So 1, 5 would be somewhere over here. So let me label this thing as A. And let me draw a line tangent like this. Okay, so got the idea? So now it says show that L is the tangent to the circle at A, and it's only for 2 marks. So I have the coordinates of A. A is 1, 5. And the gradient of AC is 11 minus 5 over 5 minus 1. 11 minus 5 is 6, 5 minus 1 is 4, that is 3 over 2. Therefore, gradient of tangent at A should be minus 2/3. That's what it says. And I think that basically proves it. Some people, what they do is that they calculate the magnitude of this thing. So that is 5 minus 1 whole square and 11 minus 5 whole square under root. This is 16 and this is 36 and that is root 52. So that further solidifies the fact, consolidates the fact that the radius is this and the gradients are perpendicular, because radius is perpendicular to tangent at the point of contact. So that is the concept that's used over here. Very simple question. Find the equation of the other circle of radius 52 for which L is also a tangent at A. Now this is a good question. What I'll do is that let me grab this and copy it, and a very simple rule is there. There's some issue, I don't know. So let me just resize it, make it small, and let me take it down like this. Now there should be another circle like this. So let me remove the unnecessary details. That is this thing. And let me remove this thing. And that's it. So let that other circle be a green circle. And that circle would be something like this. So it's also tangent. Now the center of the circle. Let me label this thing as M. So this basically, this perpendicular bisector, this line, this tangent. So basically tangent is the perpendicular bisector of the two centers. Got the idea? That's how it's possible. So one point is M, let's call it A comma B. The other point is C, I think C is 5 comma 11. And the center is actually A for these two, that is 1 comma 5. So therefore A plus 5 divided by 2 is 1, A plus 5 is 2, A is negative 3, B plus 11 divided by 2 is 5, B plus 11 equals to 10, B comes out to be negative 1. So therefore the center of that circle is minus 3 minus 1. Are they asking us the equation? Yes, they are. They have the same radius. So therefore x minus h whole square and y minus k whole square is equals to r square. So r is root 52 and that's the radius. I'm just double checking. And this thing is a square. And what is h and k? So x minus minus 3, that would become x plus 3. And similarly b is negative 1, so minus minus. So therefore this one will become plus 1, and that is the equation of the circle. So this is the paper May-June 2021, second variant. So part A, I'm stopping the first video at this point. Stay tuned.